Hello, and welcome to the RAM Commander software, world-leading tool for all tasks reliability, availability, maintainability, and safety analysis and engineering. In this tutorial, we will explain how to start with RAM Commander and provide general overview of the tool. First, let's log in to RAM Commander. I enter my user login and press OK. If you are already familiar with RAM Commander, skip this tutorial and move to My First Project video. To perform any analysis in RAM Commander, we create a project. Projects can be located on any drive, whether local or network shared drive. On this screen, we can see a list of projects. In our case, we have only one tutorial project. During the introduction, we review the tutorial project. The list of projects screen allows us to perform different operations with each project. Create project, edit, delete, copy, etc. When we want to start an analysis, we select the project. In our case, tutorial. We open the pop-up menu and select Open. Tutorials project screen is presented. Main part of the project screen presents the product tree. This product tree represents the hierarchical structure of the system under analysis. There is no limitation to the number of tree levels. In our simple tutorial project, there are only 4 levels. On the bottom level of the product tree, we usually have electronic components or mechanical components. To the left of the product tree, we have the button bar, where we can select the required analysis. All 5 types of available analyses are performed on a product tree. Operating analysis is used for reliability prediction for the operational mode of the system under analysis. Results of reliability prediction we can see below. The column OPR, or operating, FR per 1 million hours, or in the last column, MTBF in hours. Next analysis, non-operating reliability prediction is non-operational mode, usually means storage. Results of this analysis is a non-operating failure rate appearing below NOP-FR column. Now when we know how often our system fails, we know failure rate or MTBF, we can think about how we will restore our system after the failure. To do this, we go to Maintainability Prediction, calculate MTTR, mean time to repair, and MCT, mean corrective time. Maintainability prediction in RAM Commander is based on MIL HDBK 472. For electronic equipment, we can perform derating or stress analysis. During derating analysis, we compare electrical parameters of different components with the values defined in derating guideline. If one of the electrical parameters of the component is above the limit defined in the derating guidelines, such component will be marked as overstressed. And now, last analysis type FMECA, failure mode, effect, and criticality analysis. It is mainly based on MIL STD1629A. When FMECA analysis is selected, we see additional grid on the bottom of the project screen. This grid is used during FMECA. We can select any item in the product tree. Then we define potential failure modes for a current item, and specify next higher effects for each failure mode, and finally an end effect with severity on the system level. In addition to 5 types of analysis already presented and applied to the product tree, RAM Commander supports many additional analyses. We can see all of them at the button bar under Modules. RBD, Reliability Block Diagrams, is useful when we need to evaluate reliability and availability of the system with redundancy. Markov analysis supports reliability-availability calculation when we define different states of equipment and transition between these states. Design and Process FMEA supports automotive approach to failure mode analysis. FTA Fault Tree Analysis module analyzes not only single failures, like in FMECA, but also a combination of failures and calculates probability of the undesirable top event. ETA Event Tree Analysis is a logical model for both failure and success responses from initiated events. The model is useful for assessing probabilities of the outcomes. Safety. The Safety module supports safety assessment based on several standard guidelines, like ARP 4761, MIL STD 882, and more. And finally, MSG3 and RCM. These two approaches are used for scheduled or preventive maintenance development.